Hi children. Uh, today's first topic, what we are going to discuss is ohmic and non-ohmic devices. Okay. So what are ohmic and non-ohmic devices? Very simple. The devices which obey Ohm's law are ohmic devices, and which do not obey Ohm's law, they are called non-ohmic devices. Okay. So ohmic devices means you know that all the conductors, metals, they obey Ohm's law. Okay. Therefore, they are ohmic conductors or ohmic devices. But non-ohmic devices means, see, you can say there are so many example for non-ohmic devices is semiconductor diodes. There are junction diode, LEDs, light emitting diode, like that. So semiconductor diodes. Then you can say liquid electrolytes, okay, transistors, etc. are all non-ohmic devices. Okay, so so what is the difference? That is, as I told you, which obey Ohm's law are ohmic and which do not obey Ohm's law are called as non-ohmic devices. Correct? Therefore, you know that in both the case, whether it is ohmic or non-ohmic, you can say that the relation V by I, that is equal to R, okay, is valid. This is valid. Okay, so there is no problem. V by I, that is equal to R, is valid for both for ohmic and non-ohmic devices. Even non-ohmic devices, they follow this. V by I is equal to R. Okay, but what is the problem here? But R is constant, okay, for ohmic devices. Okay, V by I, that is equal to R, is constant for ohmic devices. Okay, and but V by I, that is equal to R, is not a constant. Not a constant for non-ohmic devices. This is only the difference. Okay, so that is, which means that Ohm's law is not obeyed. No? V by I is equal to R is fine, but R has to be proportional to I. V proportional to I is Ohm's law. Okay, therefore R has to be a constant if any device which obeys Ohm's law. Okay, therefore they are ohmic devices, usually conductors. Okay, therefore, but non-ohmic devices means, what is that? V by I, that is equal to R, is not a constant. Okay, therefore they are also called as ohmic devices are called linear devices, and non-ohmic devices are also called as non-linear devices. Okay, non-ohmic devices are called as non-linear devices. Why non-linear devices? Why is it given? Because if you plot a graph between V and I, okay, if it is a straight line, then it is, what is that? Ohm's law is obeyed, because V is proportional to I. Okay, if you plot a graph between V and I for conductors, definitely it will be a straight line. Okay, therefore they are linear devices. But if you plot a graph between V and I, okay, it is not a straight line. Therefore, you can say that they are non-ohmic devices or non-linear devices. Are you following? So, in that case, I'll give you some example. See, if you plot example, see V and I, if you plot a graph between V and I, okay, there are devices where, see, you will be getting a slight, if you what is not to be, this is let it be V, because so here, what is that? If this is your V and this is your I, therefore now if you plot a graph between V and I, if it goes like this, see, so actually it has to go like this, but slightly, what is it? It is deviated now. Therefore, in that case, it is definitely a non-ohmic device. Okay, and the other one, this is A. Okay, then next one is, say if I plot a graph, it is, see here, there is one, okay, junction diode. Okay, PN junction diode, that is a semiconductor device. Therefore, it is for PN junction diode. If I plot a graph between V and I here, okay, here V will take negative values also, okay, and here it is I, and here it is V. If I plot a graph, see, it is not a straight line, but instead how I am getting, you see, here it will be like this. You will be studying in your electronic devices chapter. So that time you will come to know why is it happening like this. Okay, so this is PN junction diode, and that is here. What happens here, you see, on seeing this here, V has a negative value, V, okay, therefore it has the relation between V and I, okay, depends on what the sign also. See, sign here it is negative, here it is positive. Therefore, this is non-linear. Definitely, on seeing that you can say that this is a non-linear device. Then next one, if you want, LED. In the case of PN junction diode, another one is what is a LED. See, if I plot a graph for, okay, there's no space. LED, light emitting diode. For light emitting diode, see, if I plot a graph between V and I, it is VI and this is V. Therefore, for light emitting diode, the plot will be like this, slightly, it is peculiar. It is like this, it will be like this. Okay, therefore, you can say that, see, for two values, say more than, see, two values of V, you will get the same I, correct? You, like that. So, you can say that more than two values of V, you are getting the same current. Okay, therefore, and the graph or the shape of the graph is also peculiar. This is not possible in the case of ohmic devices. So this is what is that? It is a light emitting diode, LED, light emitting diode or LED. Are you following? So these are about ohmic and non-ohmic devices, right? LED. Example, see, even all LED is also semiconductor. It is made up of semiconductor, gallium arsenide. Okay, so these are all a best example for what is a non-ohmic devices. Okay, this is an example for non-ohmic devices where Ohm's law is not valid. Ohm's law is not valid. Okay, right. Next very important topic. What is that? See, now we are going to see what is called the color code for common, what is a carbon resistors. What do you mean by say carbon? Say resistors, it is very much useful for all the electronic circuits, electrical circuits, we use resistors. So in the market, what is a commercial resistors? What we use in a mostly, they are called as carbon resistors. Why carbon means what is that? It is an it is also used for making what is a resistors like constant and I told you constant and manganese, like that. Carbon is also used for making resistor coils, resistant coils. So how is it made? These are made such that, see, by molding carbon into cylinder type. Cylinder, see, I'll tell you, there will be molding carbon like a cylinder type. Okay, and there will be a wire with both the sides. There will be wire. Okay, and this is actually covered with either a plastic or ceramic jacket. Okay, so this is what is called, this will be like that. Therefore, the shape of the carbon resistor will be like this. But how to know the value of the resistance? And it is actually, it is commercially used, vast used, what is a resistor. Why? Because actually it is very very small, compact also, and also cost wise it is very cheap. Okay, so and here we are using, here there are color codes. Now we are going to see how to know what is the resistance of this resistor? For that only several color codes are used. Several color codes are used. Now we are going to see what is that color code. So color code means there will be, see, now I'll tell you. There will be, see, first I'll tell you, see, there will be three colors usually. Okay, for example, if it is green, first one, I'll give you afterwards first. Okay, then it is yellow. Okay, now explanation I'll give afterwards. Okay, yellow. Then third one is, let it be blue. Okay, right, blue. Okay, then therefore there will be one more also, that I'll let you know afterwards. Okay, so now this is a color will be shown like this, and from that color you are supposed to find out what is the value of the resistor. Okay, so how we will see now. For that, this tabular column, because I have drawn the tabular column, it takes a lot of time. So now I'll explain with this. See, number one, first color to start with. See, first one is black. Okay, so first one is, what is that? Black color. Black, what is a symbol letter to remember is usually B. Okay, and what is the number allotted to black color is 0. Okay, and what is a multiplier? Multiply, if it is used, so multiply means 10 power, it's 0. Okay, right. Now next one, next to black is brown. First you understand, after that we will go back to this what is that color code, what is that, whatever I drawn here. Okay, brown also B only, first B, second B, you have to remember B. Okay, now next one for brown, it is 1. Okay, and multiplier is 10 power 1. Then next one is red. Red is R. Okay, then it is 2, it is 10 power 2. Then next to red is orange. This you have to remember. Next, what is that? For that one simple slogan I will tell you. Okay, then it is orange, O. Okay, orange O, what is that? It is 3, therefore 10 power 3. And next one is yellow. Next color is yellow. For yellow, Y. Okay, and for what is that? It is 4. Definitely it is 10 power 4. And you should not change the color, a number, everything will change then. Okay, the next one is green. Next color is green G, and for that it is 5, and here it is 10 power 5. 10 power 5. Then next to green, blue is once again B. See, 3 B's are coming, so that is 5. Okay, and 6 and 10 power 6. Then next one is violet. It is V. Okay, V, and this is 7, and it is 10 power 7. Right, next to violet is gray. Okay, gray it is a G. Okay, for green also G, gray also G, 8, 10 power 8. Okay, next one is you can gray, white, I think place is not white, and for white it is W, and it is 9, 10 power 9. Okay, right, let me rub because I need some more place here. Okay, so next to white, okay, next to white is actually gold. Okay, gold G. For that, okay, there is no value for, see here, a multiplier only, that multiplier, see number, then here there is a multiplier, na multiplier ka to 10 power minus 1 ho jayega. Okay, and silver, I'll tell you what is after that only. You will be able to understand, children. So just have patience. Okay, so these are all the colors that is allotted um, for different what is that, figures, significant figures. What is that? I'll tell you, let you know. Okay, right now, so now what you have to do, how to use it, that is a question, right? So now I'll tell you. See here, let us come back to the previous and here there are three colors. Here also color is there, no? See this color, I am going to use what is that, gold. Here I'm going to write gold. Three colors, silver, and two colors actually, and no color. No color. These three are very much important for giving the tolerance. Tolerance, you can say, what is the error plus how much. This is the resistance color code, that but there may be some, what is that, plus or minus tolerance will be there. This much of tolerance, okay, 20%. Okay, therefore what is that error, you can even say plus or minus 5%, plus or minus 10%. Okay, like that. Now come back to this. Okay, that once I explain, I think you'll come to know. See, let me go for the here, this is my resistance, what I have. Let me give you, okay, this is the resistance, correct? Okay, color code resistor. Okay, what is first one is, let me name it. First one is, okay, A, and this is B, and this is C. Okay, and what actually it signifies. Okay, the first strip A is there, no? A is actually the first significant figure of the resistance. First significant what is that, figure of the resistance in ohms. First significant figure. And A is the first significant figure of the resistance in ohms. Okay, and second, B is the second significant figure, okay, of the resistance in ohms, right? And what is C? C is the color of that is a third strip. Third strip is C. Okay, it indicates a multiplier. What do you mean by multiplier? The number of zeros that will follow after the first two significant figures. Okay, so A means what is the first significant figure of the resistance in ohms. It is B is the second significant figure of the resistance in ohms, right? But C, how many zeros to be followed by A and B, AB. Okay, after writing A, B, the significant figures, how many zeros to be followed? Okay, then there will be one more color, fourth one. Fourth one, let me write here. See, this is, okay, let me go for, because actually it should be golden color, but I cannot okay, let me go for otherwise golden color, exactly I cannot, so let it be. I think you can differentiate these two, right? B, and this is, let it be the tolerance. Okay, therefore this is what's called T. Let me give the name T. T is what is a tolerance. Okay, what do you mean by tolerance here, no? So for that, see, if here it is gold, fourth ring, if gold is there, then it has 5% tolerance, plus or minus 5%. Okay, silver means plus or minus 10%, and when there is sometimes only three colors will be there, no, fourth ring may not be available. In that case, it has 20% tolerance. Okay, so this is how you have to find out the resistance value. Now shall we go back to A, B, C, this color codes now? So now you see first one is green. First one is green means first significant figure. Green is nothing but, what is that value, is 5. So 5. Therefore, what is R here? R, that is equal to, what is that, 5 resistance. Okay, first one is 5. Okay, next one is yellow. So therefore yellow, see here, oh sorry, yellow, here yellow, that is, what is yellow? Value of yellow. Yellow here is 4. Okay. Therefore, 5. Next, B. B is the second significant figure in ohms. Okay. Then, next one is, okay, there is some problem with this. Okay. Therefore, see what is the first one is green, 5. Second one is yellow. Yellow means it is 4. Okay. Right. Next one is a decimal. What is a multiplier? No. Multiplier means what is it? Is blue. So, what is blue? Blue is, see, green. Next to green is blue. No. Blue is, kitna hai? 10 power 6 zeros should be there, followed by 6 zeros. Therefore, 10 power 6. Okay, therefore, let me have this one first. Okay, therefore, you can have here into, what is that? 10 power 6. That is followed by 6 zeros. Are you following? Therefore, the value is first one. Hope you are following me. See, first one is, what is that? Green. Green. Green means it is 5. Okay. Green is 5. Then yellow. Yellow is 4. Then blue. Blue. So first significant figures of resistance in ohms. Third one is a multiplier. But third one is blue. Blue here. What is a multiplier? Here you have to see only third one means then it is a multiplier. Therefore, how many it is? 10 power 6. Therefore, third ring is meant for, color code is meant for a multiplier, that is 10 power 6. Right. There's so much of ohms. Okay, fine. Then fourth ring is meant for tolerance. Na? Tolerance. Tolerance means what is that? Plus or minus. How to write? It is plus or minus. Gold ring 5%. Therefore, you have to write it plus or minus 5%. Plus or minus 5%. Are you following? So this is the value of the resistance by using, what is that? The color code. This is the color code of carbon resistors. Are you following? Now the question is, okay, first I am telling you A, B, C and then tolerance. First color is meant for the first significant figure of resistance. Second for second significant figure. Third is a decimal multiplier. How many zeros should be followed by the first two? What is the numbers? And the fourth one is, what is that? It is the tolerance. How many percent? Therefore, that tolerance, fourth one, you will get only here gold, silver or no color. If there is no ring present here, then it is plus or minus 20%. If silver ring, then 10%. Like that you have to. Okay. Hope you're following. Right. Now the question is how to remember it. Okay. So there are 3 B's are coming, 2 G's are coming. Okay. So you have to be very, very careful. First green means first G is green, second G is gray. Okay, and first, what is that? First one is black. Next, see, B, black and brown. So you should not change. First is black, then brown. Okay, then third B is also coming. That is what is called, that is blue. Okay, so how to remember? There is a simple, very important, what is that? You can say using some slogan like, okay, it is of great help for you. So how to use, how, see, I'll give you BB Roy. See, because the order you should know, no? So I'm giving you a slogan like, what is that? Okay, Roy. BB Roy. Let me go for this color. This one. Huh? BB Roy. I'll tell you what is that. Okay. Of Great Britain. I think you would have studied in your SUPW class. Great Britain. Okay. has a very good wife. Okay, very good wife, wearing a gold, silver necklace. Okay, so this is very much helpful. You have tried B.B. Roy of Great Britain. B.B. Roy of Great Britain. Okay, has a very good wife wearing gold, silver necklace. Now here, okay, now I have to highlight B, 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 first B, B, Roy, first B, black, next B, brown, Roy, red, orange, yellow, red, orange, yellow, that order. Then great, green, okay, then Britain, blue, okay, then very, violet, good, G, that is gray, okay, very good wife, W, W, here it is, what is it, white, okay, very good wife. Now next one is meant for tolerance, okay, wearing gold, 5% tolerance, silver, what is that, it is 10% tolerance, okay, gold, silver necklace, no color means, what is that, it is 20% tolerance, okay. Therefore I think B.B. Roy of Great Britain has a very good wife wearing gold, silver necklace, okay. So it is, now I can write it, it is 0, okay, 1, 2, 3, yellow 4, green 5, blue 6, okay, then violet 7, and gray, it is gray, okay. So first one green, the next one is gray, 8, gray is 8, and white is 9, and here it is 5% tolerance, and here it is 10% tolerance, silver. Okay, I think this will be easy for you to know. Okay, B.B. Roy of Great Britain has a very good wife wearing gold, silver necklace. Okay, right. Now I am giving you some resistors here. You see, resistor color code. First one is, what is that here? Red. First one is red. Okay, red means, what is that? B.B. Roy. B.B. Roy, red. See, I'll keep it here like that. Okay, okay, right. B.B. red, therefore it is 2. Okay, then yellow, it is yellow na, this color is yellow na, therefore yellow is, what is it, 4. Okay, then what is it, it is orange. Orange ke liye kitna decibel multiplier na, 10 power, therefore into 10 power 3, into 10 power 3. Oh. Okay, then after that it is gold, because okay, it is golden, okay, therefore plus or minus how many, 5%. Okay, therefore it can be even written as, what is that, 24 kilo ohm, correct? Plus or minus 5%. Okay, this is just for practice I have taken. Okay, right, next one is, you see here, what is it, it is yellow, then violet. Tell me now, first one is yellow, okay, yellow, for yellow, what is it, 4, and here it is violet. Violet, what is violet? Violet is 7, right? See here, violet is 7, violet is 7, that is a okay, violet here it is 7, right, therefore it is, yellow is 4, violet is 7, and here, okay, therefore what, this is brown, okay, therefore it is brown means, what is brown? Brown is into 10 power 1, correct? And this is brown, this is yellow, and this is violet, and this is brown. Okay, and here it is silver. Okay, this is 47 ohm, 47 into 10 power 1 ohm. Silver means plus or minus 10%. Therefore, it is 470 ohm plus or minus 10% tolerance. Okay, therefore, this is about how to find out the resistances. Okay, so this is yellow, then violet is 7. For yellow is 4, violet is 7, and it is brown. Brown means it is 1, therefore into 10 power 1 multiplier. Then silver, what is that? 10%. If there is no color, then it will be 20%. Okay, this is about what is that? Color coding. Okay, then it is very, very important. They will ask you for 1 mark, 2 mark, everything. Okay, sometimes they will ask, give the resistance, and they will ask you color code. Sometimes they'll give the color code and ask you to find out the resistance. Okay, so there are so many like that. Even 3, 4 color codes are also there, but in your syllabus only 3 color codes and 1 for what is that? Tolerance. Okay, that's all. Okay, this is enough for you. Now next one is, now we are going to see the next topic is resistance. See, combination of resistances. Now next topic is combination of resistance. This is not new to you. 10th standard you would have studied combination of resistances. Okay, there are 2 combinations possible. One is resistances in series and resistances in parallel. Both we are going to see. Okay, so first one, resistances in series. Okay, so what is that? See, I have 3 resistors to start with. What is that? I have 3 resistors. Okay, R1, R2 and R3. I have 3 resistors, R1, R2. Values are R1, R2 and R3. Now I am going to connect it in series. Series parallel connections are very common. Already you people have done in 10th standard, even capacitors in series, parallel, everything we have seen. Okay, so I have 3 resistors. Let me directly go to the topic. What is that? I have 3 resistors which are connected in series. Therefore, the resistors are, see, R1, R2. Number of waves, if I do, it doesn't mean that it is having more resistance. Okay, it is just a representation, that's it. Symbol. Okay, so it is R1, R2, R3, all are connected in series. Okay, and it is connected to a battery. Okay, fine. So this is R1, the resistors are R1, R2 and R3 are connected in series with the battery. Therefore, the current, so that the current direction will be from positive to negative, the current will be going in this direction, right? And what is the potential applied here is, what is difference? V. Okay, therefore, now you see, the current is I. The I actually, the current comes up to, okay, let me give some name here. This is A and this is B. Up to A, the current comes here. Okay, and you know that here there is, the current is not having any other option. So full current has to pass through, you know that R and I, how are they related? Okay, more the resistance, less will be the current. Okay, like that. But here R1, R2 are the different resistors only. They are not same. That is why I have given R1, R2, R3. But they are connected, when they are connected in series, the current comes up to A and the same current has to go through all the resistors irrespective of their values. Whatever may be, for example, if I take R1 is less than R2 less than R3. For example, just I am telling. So therefore, what is that? But the current through here, when all the three are connected in series, the current through each and every resistor should be the same, because the current doesn't have any option, any other branch, nothing is there. So the full current has to go through all the resistors. Therefore, current through every resistor will be the same when the resistors are connected in series. Are you following? Okay, now, okay, but the current is same. Okay, you know the Ohm's law, what is that? V, that is equal to R into I. Okay, current is same, resistors are different here, R1, R2, R3. If resistors are different, definitely what is the potential difference across each and every resistor should be different. Okay, are you following? Simple Ohm's law, V is equal to Ri. I is same because they are connected in series, but resistors here it is R1, R2, R3. Therefore, resistors are different, means potential difference should be different. Potential difference across each resistor should be different. Therefore, let me have this one. The potential drop across R1, let it be V1. Potential drop across R2 is V2. And potential drop across, okay, let me have that like that, okay, and V3 is potential drop across R3. Are you following? Okay, therefore, now what is the total? See, V1, V2, V3 are the potential drop across the resistors R1, R2, R3 through which the current I is flowing. Okay, therefore, now how can you write what is V1? V1, that is equal to, use Ohm's law, that is nothing but current is the same, but I R1, correct? And what is V2? V2, that is equal to I R2. And what is V3? Potential drop across the third resistor, that is nothing but I R3, correct? Therefore, what is the total potential difference across A and B? That should be equal to V. Potential drop across A and B should be equal to V. Okay, therefore, you can say V, that is equal to, what is between A and B? What are the three resistors are there? Therefore, all the three resistors, across each and every resistor, the potential drop is V1, V2 and V3 respectively. Therefore, if you add all the three, you will be getting, what is that? V. Therefore, it is V1. Total potential difference across all the resistors is V. That is nothing but potential drop across individual resistances. Okay, therefore, what is your V? What is your V here? V, that is equal to total potential difference across all the resistors, nothing but total current into total resistance of all the three resistors. Let that when they are connected in where? Series. Therefore, IRS. Are you following? Therefore, now that is nothing but I into RS. Why? V is equal to I into RS. Why? Total potential is nothing but total current into total resistance. What is the total resistance here? Total resistance is R in series. Series combination. Total resistance of the series combination of all the three resistors R1, R2 and R3. Okay. Therefore, that is nothing but what is V1? V1 is IR1 plus IR2 because the current is the same across through each resistor of IR3. Therefore, I will get cancelled. Therefore, you will be getting I will be get cancelled. Therefore, you will be getting RS series that is equal to R1 plus R2 plus R3. Okay, so this is the important relation. When three resistors are connected in series, you will be getting what is the net resistance or equivalent resistance is nothing but sum of the individual resistances. Okay, if there are n number of resistors, therefore what is RS? RS is equal to sigma n number of resistors. Okay, it is for 3 resistors. I have taken n number of resistors I, that is equal to 1 to n R I. That's it. Are you following? So this is what is that? Resistors when they are connected in series, you will be getting the equivalent resistance is nothing but the sum of the individual resistance. It is just opposite to the capacitors. Just opposite to the capacitors. Capacitors, when they are connected in series, what is that? 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Hope you can recall it. Okay, therefore, now this is about, therefore, what are all the conclusions here? Conclusions you can derive, very simple. Okay, what are the conclusions? Okay, number one. What is that? First one. First one, when two or more resistors are connected in series. Okay, what will happen? Number one, what is the first this one is first conclusion is, first result you can say. What is the first one? Number one. Okay, their equivalent resistance, a series. Okay, their equivalent resistance is equal to the sum of the individual resistances. Correct? Individual resistances. Okay, then number two. Okay, current through, whatever we have seen, current through each resistor is the same. Okay, and number three. Okay, potential difference across different resistors are different. Correct? V1, V2, V3 na. So different resistors are different. Okay, then fourth one. Okay, their equivalent resistance. After that I'll explain. See, their equivalent resistance is more than the maximum resistance in the combination. Okay, their equivalent resistance is, what is that? It is equal to is more than the greatest, maximum you cannot say, greatest resistance. Okay, whatever. Okay, is more than the greatest resistance in the combination. Like that we have seen in capacitors also, combination of capacitors. Okay, just you recall. Okay, therefore what is that? Now what is that? The current is, the equivalent resistance is equal to sum of the individual resistance, first one. Current through each resistor is the same. Then potential difference across different resistors are different, and their equivalent resistance is more than what is that? The largest resistance in the combination. What do you mean by that? That only I want to give you. See here, let me take R1, R2 value just like that. I think R1 is equal, let R1 is equal to 1 ohm, R2 is equal to 2 ohm. The same I have given for capacitors also. R3 that is equal to microfarad, something like that. I remember R3 that is equal to 3 ohm. Okay, therefore what is RS? Therefore RS is equal to 1 plus 2 plus 3, that is equal to 6 ohm. And 6 ohm is more than the largest, which is the largest resistance here? 3 ohm na. 1, 2, 3. Therefore definitely it is more than the greatest resistance in the combination. Therefore, which means that when you are connecting the resistance in series, the net resistance will increase. Net resistance will increase. Okay, right. Next one is resistance in parallel. Okay, so now we are going to see the resistance combination. Next one is resistance in parallel. Okay. So number 2. Resistance is in parallel. Okay, for that, see, I have 3 resistors, okay, which are connected in parallel. Therefore, what is that? R1, R2, R3. Okay, all the 3 are now connected. They are connected in parallel. I think you have idea about parallel series combination. People are in 12th standard. Already we have seen capacitors, everything. 10th standard. It is a 10th standard portion actually. Okay. Therefore, it's just a revision only. Therefore, R1, R2 and R2. Okay. And they are connected in parallel. Now, what am I doing? I am connecting it with the battery. Okay. Very simple now. What is that? It is V. The current here is I. Okay. Here the points are, this is A. Okay. Okay. Now the point here is A. Okay. And this is B. This point is A and this point is, this is B and this is A, and now I am C. Circuit. Okay. So AB. Right. Now you tell me the current I is going up to A. Okay. After that, now it has choice. That branches are there. Okay. Once again, let me take R1 is less than R2. It is okay. R3. I'm taking just like that. Okay. So that time what will happen? Up to A, the current I1 is coming. After that, it has 3 branches. It will see which is which is the least resistance in the out of this R1, R2, R3. Therefore, more current will flow through that. Okay. Therefore, now it has choice. But in the case of 3 series combination, there is no choice. A full current will go through all the resistor. But here now it is up to A, I is coming. But after that it is branching. How it is branching? Depending upon the resistance. More the resistance, less will be the current and vice versa. Okay. Therefore here more can see it is dividing into, here it is I1 and here it is I2 and here it is I3. It is branching now. Okay. And all the currents I1, I2, I3, everything, it goes through the resistor, and when it comes to B, all join, and what is that? The current which is coming out will be, coming out of B will be, once again, what is it? It is I. Are you following? Therefore, you are getting, what is that? 3 resistors when they are connected in parallel. What is that? Current here through different resistors are different. But what do you say about the potential difference? You see, all the resistors here, okay, are directly connected here. Okay, they are connected to, see, R1, one terminal is connected to positive of the supply, and R2, R1, the next other terminal is connected to the negative end of the supply. Okay, like that, every resistor is directly connected to the V here, the battery. Therefore, potential drop across each resistor will be the same. That is V. Potential drop across every resistor is the same. Are you following? That is the difference. In series combination, what is that? The current is the same, but the potential difference is different. But in the case of parallel combination, what is that? Sorry. In the case of parallel combination, what is here? The current is different, but the potential difference is the same. Okay, therefore now you tell, I think we can say what is the total current? Total current I, that is equal to I1 plus I2 plus I3, correct? Total current. What is the total current? Total current is nothing but total potential. What is V? Okay, divided by total resistance. ये total resistance क्या होता है इसमें? RP होता है. RP. What is RP? RP is the equivalent resistance or total resistance or net resistance of all the three resistors which are connected in parallel. V divided by RP. Okay. Therefore, I can say this one as, what is that? It is equal to potential drop V across I1 is the current through R1. Current through R1 is nothing but what is the potential drop across R1 is V. Okay. R1, R2, R3, the potential drop is same only now. Therefore, V divided by, okay, what is the resistance here? R1. Second one, V divided by R2. And third one, V divided by R3. Okay, therefore, you can say here, what is that? 1 by RP. Therefore, 1 by RP, that is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So, this is the formula when, okay, the resistors are connected in parallel, then the reciprocal of the equivalent resistance is equal to sum of the reciprocal of the individual resistances. Okay, so this is for parallel combination. Okay, therefore, what is the conclusion? Therefore, conclusion. Okay, what is the conclusion? Number 1. What do you conclude from it? Okay, when 2 or more resistors are connected in parallel, what are the results now? Number 1, okay, their equivalent resistance, not their equivalent, the reciprocal of, correct? Of something, not. Okay, their equivalent resistance, the reciprocal of that, the reciprocal of their equivalent resistance is equal to the sum of the reciprocals of the individual resistances. Correct? So, the result, that is the reciprocal of their equivalent resistance is equal to the sum of the reciprocal of the individual resistances, right? Number 2, the potential drop, the current through different resistors are different. Okay. Then third one. What is third one? Third one is the potential difference across each resistor is the same. Correct? Third one is, I'm not getting. That's a problem. Okay. the potential drop across different across all the resistors. I should have across every resistor is the same. Okay, then the fourth one is very important. What is it? See, the resistor, what is that? The equivalent resistance is less than the least resistance in the combination. Okay, therefore the equivalent resistance, their equivalent resistance is less than the least resistance in the combination. Okay, now how? What is that? R1 1 ohm, R2 2 ohm, R3 3 ohm. Okay, therefore what is an equal resistance? 1 by R P, that is equal to 1 by 1 plus 1 by 2 plus 1 by 3. Okay, therefore that is nothing but, if you take what is the value, the value will be, what is that here? 11 by 6, correct? It is 11 by 6. Okay, therefore what is your RP? RP is nothing but 6 by 11. 6 by 11. Okay, therefore from this what is our, which is less than, what is the least resistance here? 1 ohm. Okay, the equivalent resistance is less than the least resistance in the combination. Are you following? So this is about what is that? Parallel combination. Okay, so hope you are following. So parallel combination, therefore how to, I think I have that is okay. Here if I want to show here 1 by Rp, therefore if there are more resistors, okay, therefore 1 by Rp can be written as, okay, that is nothing but, okay, sigma I, that is equal to 1 to n 1 by R n, Ri, correct? Is 1 by Ri. Therefore this is how you have to, okay, right, that is consolidate. That is, if there are so more than 3 resistors, it is for 3 resistors. If there are n resistors are there, okay, 1 by Rp is equal to I, that is equal to 1 by n, 1 by Ri. Okay, so this is about parallel combination of resistors. Now next we'll see in the next class.